Alright everybody, welcome back and let's continue from here on. And of course I hope just I'm getting the connectivity, and once I am sure that I am getting, then I'll continue from here on. By the way, let's continue. These many things we actually covered so far. We covered the connections, session description. Again, let's make them h3 turn into, they are already h3. How about this? This must be h3 too, and so ultimately this one is not, so let's make it h3. Mainly because they look similar, that's it. This is the main reason behind that. WebRTC, this is okay, this is okay. ICE candidate gonna be h3, and role ICE servers, ICE framework, and h3. And then I have something called net. Okay, let's convert it to, that's already in h3, this is also in h3, this is the only one that's remaining, and this is how things are gonna be going on. Let's continue from here on. And right now of course I will have to turn the chats off so that I can just simply focus on one thing at a time, and then later whenever it's needed I will be turning the chats on, of course. And let me turn it off like this, and let's continue from here on. So what was the next thing that I had to cover? Let's simply even go through that. And that next thing was related to 46. Okay, these are the files. Extra. What do I have over here? Okay, some questions and answers and all. Okay, what about in 47th part? What should we do this in section? Alrighty, I think I had better just simply start learning more things and then simply continue with that. So I'm gonna be starting that, and for starting that of course I'll have to mute myself. Sorry for that. So I'm gonna be playing the music in the background.
close till I get up. Time is barely on our side. I don't wanna waste what's left. The storms we chase are leading us, and love is all we'll ever trust. Yeah, no, I don't wanna waste what's left. And on we'll go, through the wastelands, through the highways, till my shadow turns to sun rays. And on we'll go, through the wastelands, through the highways, and on we'll go. Through the highways, till my shadow turns to sun rays. And on we'll go, through the wastelands, through the highways, and on we'll go. See the horizon, turn us to thousands, and we'll grow in number, fueled by them. To see the horizon, turn us to thousands, and on we'll go, through the wastelands, through the highways, till my shadow turns to sun rays. And on
empty. The only thing I can see is my own silhouette. I'm getting stronger, step by step. The clock is ticking, but there's no time for regrets. I've been flying from town to town, from London to Taiwan. I've been all around the globe, trying to protect your soul. We are heroes tonight. We will fly above the sky. We are heroes tonight. Yeah. We are heroes tonight. We will fly above the sky. We are heroes tonight. Feel like a dynamite, ready to explode right up in the sky. I need you to listen, I need you to hear, and don't show any fear. I've been flying from town to town, from London to Taiwan. I've been all around the globe, trying to protect your soul. We are heroes tonight. We will fly above the sky. We are heroes tonight. Yeah. We are heroes tonight. We will fly above the sky. We are heroes tonight. Town to town, from London to Taiwan. I've been all around the globe, trying to protect your soul.
That's good.
close till I get up. Time is barely on our side. I don't wanna waste what's left. The storms we chase are leading us, and love is all we'll ever trust. Yeah, no, I don't wanna waste what's left. And on we'll go, through the wastelands, through the highways, till my shadow turns to sun rays. And on we'll go, through the wastelands, through the highways, and on.
Alright everybody, so welcome back. It's been quite a lot actually, just finally got that done. Okay, but there's actually a lot. It's like I have to revise that anyhow, otherwise I'm gonna be forgetting everything. It's been too much. Ultimately, the whole process of actually getting a WebRTC connection ready, ultimately getting two peers connected, let's simply go through that once and then simply of course I need to work on my this stuff as well. Having said that, just a minute, let me get that thing here. Hang on for a sec. I have to just simply stop sharing the screen for a while, and just a sec, gotta do something, and then I'll be back really soon. From here, copy it, close this, paste it on the, let me paste it on the, come on yaar, I should be getting there, on here, over here on the desktop. And this is the PNG that I have that simply explains everything from the beginning till the end, thanks to my tutor. He actually provided that, but yeah, it's gonna be super duper helpful, and that's what I'm gonna be using over here to just simply understand things and all. So this is gonna be the process of knowing it or learning it. Let me turn the dark mode is already on. By the way, let's talk about the connection. First of all, this needs to be talked about anyhow, and even if needed I may have to rewatch the video, but this is a super duper important thing. Okay, why am I unable to zoom in and zoom out? Oh, it's done like this, 100%. Yeah, now I can do that. So let's start it from the beginning. So what are we even gonna be discussing? How a WebRTC connection is made. So we will be talking about that, and it actually starts from here. So the whole process starts with this particular point. you have peer 1, you have a peer 2, and then in between you will have signaling server. Again, signaling server is mainly important when you need to connect, and after that you can just remove the signaling server, and then you will be able to, once you are connected to the another peer, you don't need a signaling server. Ultimately that can be a WebSocket server, of course, so you don't need that WebSocket server, rather you can just directly talk to the peer. But before that, you have a peer, oh come on, here we are, you have a peer 1, okay, and this peer 1 will already be connected to the peer 2. So peer 1 means first user, peer 2 means second user, and they are connected using a server, and that server is WebSocket server. If you have ever used WebSocket, so you must know what does WebSocket do. First of all, WebSocket is bidirectional. Bidirectional in the sense you can send the request to the server, and the server can send the request back to you. So it's just gonna be like that, and that is something that happens at the same time. So ultimately what happens is that you send a request to the server, server sends a request to the another peer at the same time. Another peer sends you the request, sends the request to the server, server sends the request back to you. So it is bidirectional, that is why it is called bidirectional. So ultimately using WebSocket server, you just get connected. Once you are connected to the peer, then what happens? You create RTC peer connection. Of course, once the RTC peer connection is ready, then you create a data channel. Using data channel, what do? Using data channel, I mean, you just simply add the type of data you wanna send, and once that is done, then you offer gets created, because as soon as your data channel, I mean, you create the data channel, ultimately modify the peer object, at that time this offer gets created automatically, and when this offer gets created, at that time you send a signaling server. Ultimately you send this offer to this particular server. Once the offer is created, you just simply send the offer to the server, and server simply pushes it to the peer connection. Okay, once the peer connection gets your offer, then it simply creates the RTCP peer connection. Once the RTCP peer connection is ready, set a remote description offer. So this particular, the offer that it gets, it simply sets that offer to the remote description, and that's it. After that PC remote description is set, and once that is set, you don't really need to worry about anything at all. So this much is done, right? So ultimately it sets the remote description. After that, over here, once the offer is created, then we are setting the local description over here. So on the another client peer 2 side, remote description got set over here, and on the peer 1 side set, I mean local description is setting with the help of that offer. Once that is done, then PC local description is set, PC in the sense of peer connection, and I hope I'm not facing the network issue right now. Once the peer connection is ready, then you set the flag, right? Media type you set, like okay, this is kind of the media type that you'll be sending. Once the flag is set, then ultimately at that time your ICE agents start working. So as soon as your offer gets created and offer gets set in the local description on the clients 1, ultimately peer 1, at that time this ICE agent starts working. And what does this ICE agent do? Who am I? Give me possible public routes that other can use to send and receive data, set it in my M flag. So ultimately what happens is that M flag simply tells the media type, exactly what kind of media I will be sending, and this ICE agent simply makes a request to the Stun server. Again, I have already configured it, so it will make a request to the Stun server. Stun server, then it will get many candidates in the sense Stun server is gonna be sending many candidates. Some Stun servers it will get automatically from the host side only. Some Stun servers it will get from the some candidates, not Stun servers. So some candidates will be here from the host side, some candidates will be here from the Stun server side, and we will be using those candidates only. And those candidates can be using UDP protocol as well as TCP protocol. They can be using any one of them. And once that is done, then what I do, I update my local description, because by default I just had only offer in my description, but as soon as I got the candidates, at that time I will have to update my local description. Once the local description got updated, then I send a signaling server, and it pushes that, and I just simply add the ICE candidate. Having said that, the candidate ultimately I send all the candidates here. So once I got the candidates over from here, and after getting them, I'm just simply sending a signaling server push to peer 2. Ultimately candidates are pushed here. Once the candidates are pushed here, add ICE candidate. So ultimately those candidates are even actually added over here. And update remote description. First of all, even at the top we created the remote description, and once the ICE candidates are here, we are just simply updating the remote description again. So it's as simple as that. What happens overall, you create the remote description over you create the offer over here, you send the offer over here, local description gets added over here, remote description gets added. And once you get the ICE agents, ultimately once using ICE agents you get the candidates, then you update the local description over here, same you update the remote description over here. So same thing is going on so far. And this is how things actually go on. So this is the overall thing that actually happening. Just after that, you register the data channel listeners. Data channel listeners in the sense what kind of data it will be actually getting. The same thing you did over here as well. Just in here you created the data channel and you will be just simply listening to that over here. So you are just simply listening that, and answer, you will be sending the answer from here, because registers data channel listener in the sense your answer is ready over here. When you created the data channel, inside the data channel what you are specifying, inside the data channel you are just simply specifying that, and this is the type of media that I will be offering from my side, right? So once you have that, once you know exactly what kind of data you will be sending, then you are creating the offer, and the offer is automatically going to be created. Similarly over here, once you are registering the data channel listeners, the answer will automatically be created, and once the answer is created, you are sending the answer back, and once it gets the answer, it will add the remote description, and that will be added, and after that again same process is going to be repeated. Then once, and on the peer 2 side you will be setting the local description. Once the local description is set, M flag will be added, like okay, this kind of data it is accepting. Once that is done, then ICE agent will be responsible for making a request to the servers and will be getting many candidates. Once it got the candidates, then it will be just simply updating the local description first of all, and it will actually signal those candidates to the peer 1 side, and it will just simply add those candidates in the remote description. Once this much is done, that's it. So ultimately what you did, pretty simple thing. On your peer 1 side, first of all, you added the data channel, then the kind of data you wanna offer, that got set, then offer got created, and once the offer got created, that's it. You are sending the offer here, and offer is getting saved on the peer 2 side but in the remote description, and the same offer is getting saved on the peer 1 side but in the local description. Once it got set in the local description, then you are getting the flag, like this type of data I will be sending. Once it is clear, then you are just simply getting the candidates. Once the candidates are here, you are sending the candidates back. Local description is getting updated on the peer 1 side, and remote description is getting updated on the peer 2 side. This thing is done. Then after that you get you create the you register the data channel listeners. Ultimately this kind of data I will be listening, and then answer gets ready, answer gets saved in the local description, and you send the answer on the peer 1 side as well to the peer side, and over here remote description gets ready. Once this thing is done, then you even once you have your answer and you have the kind of data that you will be sending, you will be listening to, so you will be setting M flag, and then you will get lots of candidates. Once you got the candidates, you are just simply sending the candidates on the peer 1 side. Once all these things done, then what will happen over here, that you will have many candidates. So candidates are gonna be in the local description as well, and you will have remote description candidates too. So you have local candidates, you have remote description candidate, and then what happens is that you will be just simply sending a stun binding request, like okay, kind of randomly you will be sending the request using different candidates on the basis of the priority and all. And once those candidates arrive here, then connection connected, if it actually gets connected, ultimately local candidate and remote candidate, they are okay with each other and they are ready for the connection. So ultimately connection state is gonna be connected, stun binding request will come here, and connection will be connected over here, and that's it. Your data channel will be ready, and right now from here you can just simply remove the server, and you will be able to talk to the other peer directly. Wow, it's been actually super duper helpful. Nothing could be more important than this actually right here, because without this it would have been literally next to impossible to understand like exactly how the things exactly work, but this simply clarifies everything. Exactly this happens like this and all, and I'm really thankful to that particular instructor. Again, you can look for the course on Udemy from, and the name of the course I didn't remember. That is a WebRTC course, and he's a where like the name is WebRTC course, very informed in 2026. Just go with that, and the name of this tutor is what is his name? I think its name is Clyde Matthew, if I'm not wrong. I may have been pronouncing it wrong, but okay, you can just simply look for it. But the course he is providing, that's really amazing anyway. So I really appreciate his work over here, because he made me understand what else could be better than this, right? And alrighty, let's continue from here on. And this time I will be talking about some other things and all. It's been pretty. What is the size of this PNG? Let me even check the properties right here. And the size of PNG is oh, where is that? Import. Can I simply save it here? Let's check this thing. /PNG. Forget about PNG. Let's save the image. Just like this. I should be able to just simply upload it, and I will be uploading it from desktop, and this is the image that I have. And turns out it is not going to be uploaded because the file size is too much actually. That's fine. Can I upload it in the form of a file? Let's see. Can I do that right now? Even that cannot be done. File size is actually a lot, and because of that thing it cannot really be done. So let's not worry about that. Just simply have these many things. Quite I've done a lot. At least the theory is done, and that simply means that once this particular theory part is done, just a minute, give me a moment. So initially I had the introduction to the WebRTC, and just after that this was kind of the introduction part. So I can simply say as page introduction. This is gonna be the part of the introduction. So first one is the introduction that I had, and just below this I had a theory. Let's make it a page over here. WebRTC theory, and inside WebRTC theory I have these many things. So by the way, in the introduction part I had this particular thing, and in the theory part I had these many. So I will be just simply copying, and this is the section of theory. Of course I will be keeping it inside theory. There's a lot to learn. By the way, in the introduction part, let me even check that. Oh yeah, normal things were discussed. Just after that I learned the things about theory and all. WebRTC theory, prepare environment and set up a node server. That's the what I'm gonna be focusing right now. But before that, infrastructure, coding files, diagrams. There's gonna be a quiz. Just a sec, let me reload the page. By the way, this is how things are actually gonna be going on. Alrighty, just a sec. Almost it should be done right here. And next I can just simply continue from here on. Just a minute, give me a moment. Hang on for a sec. Alrighty, this thing is done. Close this as well. Let me open my WhatsApp. Now even I have to learn more. Like, it's not the end. There's a lot. Like, there's 7 hours of course that is remaining. That simply means that I gotta learn as much as possible, and the sooner the better. I don't have lots of time to just wait now. Alrighty, let's continue. And I will mainly be focusing on getting it done as soon as possible. The simplest thing. So let's open another one. Alrighty. I've added several comments to our coding files in WebRTC. You can download it if you like. Okay, so there are these things. And files. Here are the files. What are there? I have no idea. What's there in this particular file? Just a minute. Let's go here. This is the one that I downloaded. I can double click on it. How to extract a file here? Okay, I got that extracted. And starting, okay, there is just HTML related stuff. That's fine. The good thing is that in Ubuntu you don't need to download any extractor. It simply extracts the files automatically if you are downloading any zip file or RAR file, RAR file and all. Okay, apart from this particular thing, just a minute, give me a second, and then I'll continue from here on. So this much is done, the photo is gonna be there, and let's simply go through some of the quizzes and let's see whether we are able to answer them right or not. Okay, the first, what is the primary purpose of the stun in WebRTC? Primary purpose of stun, to establish a direct peer-to-peer connection, to discover the public IP address region port of a device behind net. Okay, so this is the second one, that's gonna be right over here. Let's click on the next one. When is turn required? When is turn required in WebRTC communication? When do we need turn? So when direct peer-to-peer connection is not possible due to restricted net configurations, when both peers are not on the same local network. So ultimately, yeah, this is gonna be the first one actually. Let's go with the next one. Which of the following statements about turn is true? Turn servers are used to discover public IP address. Turn can introduce latency due to routing traffic through a relay server. Turn is always preferred over stun for net traversal. Turn is always preferred over stun for net traversal. Not really. The second one should be right. Let's see. Yeah, that's right. Let's continue from here on. Regarding turn servers in WebRTC, which of the following is true? Turn server. Developers must write custom turn servers for software to no. Turn servers are generally pre-built software you deploy or rent and require no coding in WebRTC client. Turn servers replace the need for turn servers and machine learning servers. Oh, just a minute. Amazing, yeah, I mean, impressive. Just a sec. What is this? Okay. Do I have to do it? Just a minute. Or this is the response from ChatGPT. ChatGPT. This is the response from ChatGPT. Okay, just getting some things right here. Let's keep my mobile over here so that I can actually get in touch with this anytime. Alrighty, let's continue from here on. By the way, we were just simply going through the quizzes and all, and meanwhile I can just simply keep it on. And WebRTC theory, we have these many things inside the WebRTC theory section. Regarding turn servers in WebRTC, which of the following is true? The turn servers are generally pre-built with the software you deploy or rent and require no coding with WebRTC. Yeah, that's right. The second one should be right, and that's right. Let's continue. Okay, you are starting to understand turn servers. Now I'm going to throw you a hard question. Are you ready? Okay, if your WebRTC application defaults to using turn server to relay data, why might this still be better than just routing data through a custom WebSocket server? Turn servers relay encrypted media streams that are optimized for real communication, preserving privacy and reducing latency compared to generic WebSockets. Relay turn servers require less infrastructure and bandwidth than WebSocket servers, and regardless of usage, turn servers eliminate the need for any peer-to-peer connection. Hence, turn server always provide faster connection. I think the first one should be fine. Yeah, that's right. Let's go. WebRTC infrastructure. Why is the important? Why is the ICE important in Web ICE? Okay. It eliminates the need for stun and turn, not really. It simplifies the coding process, not really. It dynamically selects the most appropriate net traversal method based on network conditions. It goes, yeah, third one. Let's continue. In the context of WebRTC, what does the RDCP peer connection object represent? One end of WebRTC media streaming and the entire signaling server peer connection. RDCP peer connection, the media stream being transmitted. One end of WebRTC. Yeah, that's right. One end of WebRTC session. That's right. Sorry. What information is typically included in WebRTC session? Only WebRTC session. Only the media stream details, user credentials, authentication tokens, sessions, ESDP, offer, answer, IC, connection endpoints, ultimately session ID. All these things are gonna be included there. Oh, where is she gone? Mom is calling me. Just a minute. Got some work again. Hang on for a sec. Congratulations, got some work again. That means I will have to leave, but before that let's simply go through it. 9 number is done. Okay, which properties of RDCP peer connection object hold session and description? Something holds session and description, that's right. And what is that? Which property of RDCP connection hold local and remote description? That is right. Yeah. So it does contain the session, right? Yeah, session ID and all descriptions. Object of session descriptions, fine. How does the RDCP connection RDC peer connection object handle session descriptions for both peers? It automatically generates session description for both sides, so each peer maintains its own RDCP peer connection instance and exchange session description through signaling server. This is the second one. I'm just simply going ahead. Last two are remaining. What must happen for two peers to establish a WebRTC connection? Both peers must use the same IP. One peer must initiate a connection without any prior setup. They must exchange their session descriptions through a signaling server. This is gonna be the one. Last question is gonna be here. What does AS and RCP flag in SDP initiate? The peer is only send media or data. Here both sending and receiving. This is gonna be the one. Alrighty. Okay. One got wrong, and most of them are correct. And now from here on we can just simply go ahead and get the things done, right? Okay. One in this section is just solely about WebRTC. I can't stress enough how much fun it will be code along with me. As you know, WebRTC needs a signaling server to work its magic, and in this section we are going to set up a Node.js server together. I share some tips and along the way, like how just up your package JSON files with scripts and don't want to keep things streamlined and so much more. But hey, if you are already a Node.js service and know your way around setting up your socket, it's not easy to skip ahead. No hard feelings, and remember at the end of this section you will find all WordPress files waiting for you, so you can jump right into the next adventure of writing up. Let's roll our course, listen. let's go again. Alrighty, by the way, and from here on I will just simply be going ahead and all. So that was it for now. I actually got some work, so I'll have to get that done, and then once that is done, I'll be back and continue from here on. Until then, yeah, take care and see you. Let me just end this.